Welcome back, guys. Here an application of template matching. We can dive into the template matching as a means to detect features in an image. So here the template matching works by sliding a source template image and making a difference at every possible location against the reference image. The difference shows us how close those two images are and together, and if there is any close matches between the template and the source frame, it will indicate the area as a very bright spot in the resulting image. So now we are reading the both images here, the template and the players, and we need to create here, we can say like that, the run the template matching command and type the just here result is equal to cv2 dot match template, and here we are just going to pass through the frame template and cv2 dot tm underscore ccoeff underscore normed. This is one of the several different methods of doing the template matching, and here into the OpenCV documentation for all other options. At this point, we can already take a look at the result by taking the cv2 dot show, and then we will pass the name of the window called the matching comma result into it, like this way here, cv2 dot show matching, and here pass the result, and the cv2 dot wait key here just for, and cv2 dot destroy all windows. So here just we can run into through the python 3 01.py. This is our file here. If you see here, this is the matching result of our template matching. We can see how this different compare the source image to the template. So so far so if we were code the uncode the animate the template working, it would work for moving this image across the source frame like so at every possible you can say like that, every possible location. One thing to note is the size of the matching frame is actually less than the size of the original frame. This is because we were to overlay the two AUs. So if we see here, this one is the matching one. Just we need to show here to differentiate the show. Here this one is the frame, and here frame, and here cv2 dot show, and here is the template and template. So this one is just escaping it and running the code again. If we see here, so if you see here, this one is the frame and this one is the template. Okay, so if we were the animate the template working, and then you can see to note that the size of the matching frame is actually less than the actual size here. If you see here, this is because we were overlay the 2U would not, the template file can only match in the top left hand corner of the original frame, which means the first pixel of the difference value is actually at the center of the template at the point. In the same way, the last pixel does a different at the bottom right handed corner of the this matching here, means like this one is like that way. So if we move the matching window out of the way, we can see as the approximate location of our original ball. So even though we are using a different ball as our template, now let's see if we can more exactly determine what the location is. I'm going to escape and exit from here, and just going to write the code here for min well, maxwell and min location, and max location is equal to cv2 dot min max location, and just pass the result in it. So here we are just going to print the max well and the max location. So whatever the result is, so just we are now print the position of this, and then we are just going to cv2 dot circle on that specific point result, and the max location, and the 15 and the red color point, and just put the location whatever radius, like such as the 15 for example, and the color to pure white, and we are in the grayscale image, so we only have to pass in one value and inline thickness of the two. At this point just I would like to means like press save, and then here this the matching result will be the appear like that way. So let's execute this code again. cv2 has no attributes. Destroy all windows. Destroy all windows. Why it is showing? Okay, let's call the function again 01 dot pi, and then see the result. Here if you see here, and on exact location of the ball, they will got the circle here, and use the original soccer ball from the image itself and template, and also we would find the result matching value here would have been much closer to the real one. Okay, so that's the basically the application of template matching, and you guys can do practice for it. Thank you, and bye for now.